Okay guys, welcome back. Part 2 of the parallel presentation. So we went through the introduction, we found out the basic concepts of parallel circuits, especially focusing in on the big three: resistance, voltage, and current. And we had decided to find total resistance, we add resistors up the 1/over way. That's the whole conductance thing that was in the previous video. So we add up resistance the 1/over way, and then current divides proportionally in a parallel. All the individual currents add back up to their total current, and then voltage stays the same in a parallel circuit. So what we have on the board is just the formulas that say just that. So don't let the formulas freak you out. But look, take and pause it, write them down. So what we're going to do is we're going to take and add up resistances the 1/over way to determine total resistance. After we have total resistance along with the applied voltage, we can take the voltage divided by that resistance to get our total current. So our total current is total voltage divided by total resistance. Now, one thing we had determined before is that voltage stays the same. This is just the mathematical way of representing voltage stays the same. So total voltage is equal to the voltage for R1, which is equal for the voltage for R2, R3, so on and so forth. So voltage stays the same in a parallel circuit. Now, in order to find the individual current, since we know the voltage across each one of them, we can simply take excuse me, the voltage across that resistor divided by the resistance of the resistor, and it'll give us the current through the resistor. So the current through R2 would be the voltage of R2 divided by R2, Ohm's law, and then the current for R3, voltage divided by R3, or voltage of R3 divided by R3 will give us the current through R3. And then again, as a check, we want to make sure that all our individual currents add up to equal our total current. Okay? So these are the formulas. Make sure you get them. But it's all Ohm's law. The only thing that's different is this total resistance formula. Okay? So get them real quick. So let's try one real quick. Notice junction points. This is what separates parallel circuits from series circuits. We've got multiple paths. We need junction points. All right. So we have a circuit, parallel circuit. got 3 resistors in it, got a total applied voltage of 10 volts. First thing you want to make sure that you know, and what you do, voltage stays the same, folks. So, you know, that has to be more of a working concept than just some vague notion. So voltage is the same across each one of them. So now we have to solve for total resistance. I got a 3K, a 2.6K, and a 5 kilo ohm resistor. So we're going to add them up the 1 over weight. So it's the 3EE3 1 over plus 2.6 EE3 1 over plus 5 EE3 1 over equals, and then 1 over. And it gives me 1.089 kilo ohms. 1.089 kilo ohms. So my total resistance is 1.089 kilo ohms. Okay? Now to determine total current, we take our total voltage and divide it by our total resistance. So we're going to do that now. Take that. And it gives me 9.179 milliamps. So that's 9.179 milliamps. Okay? So now, this is a 7. So now to find our individual currents, all we do is take the voltages divided by the individual resistances. So we're going to take the 10 volts divided by the 3 kilo ohms, divided by 3 EE3. That gives me 3.333 milliamps. 3.333 milliamps. We got the 10 volts and the 2.6 kilo ohm. Excuse me. So that's 10 volts divided by 2.6 EE3 equals, and that gives me 3.846 milliamps. And then we take the last one, 10 volts, divided by the 5K. 10 divided by 5, of course, is 2 milliamps. Okay, now just to double check, make sure that we've done this correctly, I'm going to add up my current. So that's at 2 milliamps plus the 3.846 EE negative 3 plus 3.333 EE negative 3 equals, and it gives me 1.7 or 1. It gives me 9.179 milliamps. All right, so then we know that we've done the problem right. Okay, so it's as simple as that. You add them over the 1 over weight, that's the big new formula. Once you get your total resistance, you find your total current. After you find your individual currents, you add them back up, make sure that you come out with your total current. Okay? All right, so I'm going to put, we're going to do 3 of these for our homework. So I am going to put different values up there. Make sure you pause it in between because I'm going to erase them, and then you get all 3 circuits. Okay? And we're solving for the same thing that we always solve for. 3.2 kiloohms. So the first problem is 8 volts total, 750 ohms R1, 3.2 kiloohms R2, and 4.7 kiloohms R3. The second problem has a 15 volt total voltage source. R1 is 8.6 kiloohms, R2 is 12 kiloohms, and R3 is 7.5 kiloohms. And look, I want y'all to draw these diagrams out and then put the answers below it. Okay, that'll let me know what you're working on. And then the last one, so for the last one, what I want y'all to do, got a 3.2 volt total applied voltage, 75 kiloohms for R1, 150 kiloohms for R2, and 330 kiloohms for R3. Okay, so get these written down, get those analyzed, take a picture of it, send it back in an email. That way we'll get credit for a day. Even if you turned in your series quiz this morning, that doesn't get you the attendance. That gets you the series quiz grade. This gets you the attendance. So send this back to me. And guys, look, I'll see you next week. Hang in there. We're going to do what we can. And like I said, I'm getting to the questions as quickly as I can. So if you have any, by all means, send them on in. All right. See you next time.